So to finish this problem, we have the negative 160, and we're adding 4 over and over again to go from the 50 to the 55 answer. And so the shortcut would be negative 160 plus 4 times x, since we don't know what x is. So if I would go back to the graph, which is here, and if I would stick in that equation, negative 160 plus 4x, does it work? So yours is already open. See if you put that equation in, that expression in, with y equals, does the line go through all those points? And if the answer is no, then where do you think we made a mistake? Is our beginning value, is it not negative 160? Is the number we're counting off by, is it not 4? Is it count by 1s? So you see if you need to make an adjustment to either number. But the end result is we want that line to go through all those points. So I'll give you a moment to do that. Turn the video back on when you are ready to continue. So negative 160 plus 4x. And you'll notice that it's off a little bit. And this is a mistake that I made. So I need you to go back to the table here, because the 40 and 55 is actually supposed to be 50, 40, 55, 60. And I have 55, 40 instead of 50, 40. So this number here, x number, is actually off by 5. So it should be 50. Then if you go ahead and change this to 5 and then continue down, and it looks like it's lining up. So, with the table being the right data, the equation we came up with will work. So in the problem above it, if you turn the button off, you can get rid of the dots, and if you want to get rid of the graph, just turn off the circle here, and delete it. So we're going to turn this one on, and so this is clearly geometric, and we're trying to come up with an equation that will work here. So like the last one we count off by 5s, and we had to make an adjustment to make it count off by 1s. This time we're counting off by 10s on the x value. So this is a geometric, which means that there needs to be some kind of r value. Understand when we get that common ratio, it's going to be based on counting off by 10s. And we need to figure out what it is when we count off by 1s. So the nice thing in this one here is we don't have to worry so much about the x value, x of 0, or u of 0. If we want to use u, doesn't matter. Probably be best if we did u. So can you come up with the geometric recursive formula for this? Keep in mind that we want to be counting off by 1s. So this table here is starting off at 0, and whatever you come up with, we need to rewrite the r value so that it will work by counting off by 1s instead of 10s. So work on it, talk with your partner, see if you come up with an answer. And when you have an answer for the equation, let's finish off. Again, this is task 2 from the handout, so if you want to go back to the handout you received and do all your work there, that'd be great. And then turn the video on when you're ready to continue. And this one's a little challenging, and challenging as in there's actually some other steps that we have to do to actually find the answer. So hopefully the first thing you did was try to find that r value. Because without knowing the r value, we're not going to be able to figure out the recursive formula. So I'm going to do 3 of them, and we're going to see if there's a consistent r value here. If you haven't done that, go ahead and turn the video off, find the r value. Is it the right number, and same number? And if the answer is no, then what I'd like you to do is I'd like you to find the average r value for the 3 numbers that are here, and then turn the video back on. So I found the r value was not the same, so we need to find an average of those. And so I did a little bit of rounding. So you have 0.78, 0.769, and 0.783. And we want to find the average. So if we don't have the average yet for these three numbers, go ahead and find the average and then turn the video back on. So to find the average, you really have to find the answer to the numerator first, and then you're going to divide by 3. So hopefully you got the average to be about 0.777. Now that's 0.777 for a 10-year increment. Now, to be able to do this problem, that is the R value, 0.777. What we have to do is we have to turn this R value back into a rate. Because what we have to actually do here in this problem is try to figure out what the rate would be per minute or per hour, whatever, per day, whatever it is. And so we've done something similar to this last week, where I gave you an annual rate, and then I asked you to find a quarterly rate, or a semi-annual rate, or a monthly rate. So we can find out this rate, this R value, for example, but I need to break it down into an annual, which would be the total, and then break it down into the number of pieces that I want to use here. So those pieces will be based on 10 years. So turn it into a percent. You can do that before, and then turn the video back on. So in doing turning an R value into a rate, the first step is the multiply by 100. So that's going to give me 77.7%. Then from here, we take that answer and we subtract 100% from it. Now keep in mind, sometimes we're going to get a negative number. And we should get a negative number here because this is a decay. This table is going down in value. So we go from 100 to 78 to 60 to 47. So we should end up with a decay or a negative answer. So our rate is actually without the negative sign. So our rate is 22.3%. And it is a decay because it is going down. So here's the question: if my rate from here 0 to here, if my rate is 22.3%, and our u of n equals u of n minus 1, that number there, whatever we put in there, has to be for 1 year. What should the rate be for a year? If the rate for 10 years is 22.3. So we need to figure that out. So the rate for 1 year. And then once you find the rate for 1 year, then what is the R value? And that's what we're going to be multiplying by here. So we can figure it out and then turn the video back on when you're ready. So basically, like we did an annual rate, if I wanted a monthly rate, I took the annual rate and divided it by 12. When I did quarterly, I took the annual rate and divided it by 4. Semi-annual, the example I gave was property tax. We do property tax twice a year. Semi-annual is twice a year, so we take the annual rate, we divide by 2. So to get a rate here that's based on 10 years, we're going to hit 22.3, and we're going to divide it by 10, which means the rate is going to be 2.23%. That's the rate. So what would be the R value? So we got to turn this into a decimal number and then figure out the R value. If you've not done that, go ahead and figure that out based on 2.23%. And then turn the video back on. So to turn this into a decimal number, we take that and divide by 100. So the R value is going to be 0.0223. That's going to be that decimal number. Or if you wanted to keep with the percent, keep in mind we are doing decay here, so it's going to be less than 100, so we can take that 1 minus 0.0223, find the R value, or you can take 100%, subtract away 2.23%, get that percent answer, and then turn that percent into a decimal number. So you have two choices here. One like the textbook's been doing it, 1 minus 0.223, or take 100% minus 2.23%, find out that percent, and then turn it into a decimal number. Either way, same answer. So go ahead and figure that out. If not, turn the video back on when you're finished. So hopefully you got it to be 0.99777 We got one too many nines here. Try that again. How about 0.9777? So about 97%. We're taking about 2% off, and so it's going to be about 97%. So if I multiply by this number 10 times, I should get 78, or really close to it. So we got a U of 0 to 100. Our number we're multiplying by over and over again is 0.9777. Go ahead, I'm going to erase some of this stuff. And so what I'd like you to do is think about if I take the 100, if I would multiply by 0.977, and then by another 0.9777, and another one, and if I keep doing that a total of 10 times, what is a faster way of going from here to here to check to see if I have the right answer? Go ahead and turn the video back on when you are when you think you figured it out. Check it to see if you put it in your, whatever that shortcut is. Put it in, see if you actually end up with 78. So hopefully you decided if you have a repeated multiplication problem. Hopefully you decide that repeated multiplication problem can be rewritten as an exponent problem. So we're starting at 100. We're multiplying by 0.977 10 times. We could rewrite this as 100 times 0.977 to the 10th power. And if I put it in the calculator, we end up with is 92.240. So we are a little high, because we want 78. So my recommendation is can you figure out how to adjust that last number? So I make it 97.8, 97.6, 97.5. See if you can figure that out. And when you have that expression, I'd like you to put in the equation. Now keep in mind that what we have here, the exponent, that's going to be our x, because we don't necessarily know how many, what number we're looking for on the table. So try to figure out that equation. Again, the exponent, this is going to be x. Type in your equation and see how close you are to go through all of these points. When you're finished, turn the video back on. So this problem, we had 100 times 0.977 raised to the exponent of x. And if you'll notice, we are very close. But as I mentioned, that we were a little high, so I suggested that we go up to 8, for example. And if I go up to 8, you'll notice that, or 9, it's actually getting further away. So 7, did you try 6? Looks pretty good, but can we get better? 5. Looks like 5 is a really good choice here. So for this table here, the best fit equation is going to be y is equal to 100 times 0.975 to the x power.